All right, Math Whiz, Math Leaguers. I'm back. I'm actually still here. I'm making both videos at the same time. I'm still in Mr. Kuhlman's room at Archbishop Moeller High School in Cincinnati. Like I said, fun to go to some different places. And I'm just gonna do the wrap up. I'm gonna solve some of those problems that I gave hints on. I'm gonna tell you the joke for this week and encourage you to have another great week. Remember, we're at the end of week 2. Remember, in week 4, we're gonna have a live Kahoot. Something will be sent out on that where you can, you can get in and speed is gonna become a thing. So if you're behind, if you missed some problems, maybe you'll be able to catch up. We're gonna give bonus points for how well you do on the Kahoot. We're also hopefully pushing out some merchandise, some gear, some t-shirts and stuff like that. So be on the lookout for that. But here we go. Here's our video for the week 2 wrap up. You can tell I still have this left up here on Mr. Kuhlman's board. I changed some of it, but so the problem was a 5x10 picture is in a 26x17 frame. I'm gonna go ahead and make this bigger so we can see it. So we're gonna make that's a terrible rectangle. We're gonna make that 26, we're gonna make that 17, we're gonna make that 5, we're gonna make that 10, okay? So this distance here is 17. If this picture is centered, that's 5. So this plus this must equal 12. So this must be 6, okay? So this is 6. 6 right there. This is 6, okay? 6 and 6 and 5 is 17, okay? This is 10. If this is 26 across, then that means that this plus this must be 16, so this needs to be 8 by 8, okay, which means this distance is 8, and this distance is 8, this distance is 8, okay, 8, 10, 8, that's 26, and then it's literally asking for the distance from one corner of the picture to one corner of the frame. We know that this is 6, so it's the hypotenuse of that right triangle. Won't even do it. Pythagorean theorem, a squared plus b squared equals c squared. That's a 6, 8, 10. It's a 3, 4, 5, but it's double. So the answer to this was 10 inches. Okay, I'm gonna actually give the answer to number 12 in order to talk about the answer to number 3, but the answer to 12, the Fibonacci sequence, it's asking for the 15th Fibonacci number. Remember that you add the 2 previous numbers. 0 and 1 is 1, 0 and 1 is 1, 1 and 1 is 2, 1 and 2 is 3, and so on. 5, 8, 13, 21, 34, 55, 89, 144, 233, 377 is the 15th Fibonacci number. What does this have to do with this golden ratio, the Greek phi, okay, where the length plus width compared to the length is equal to the length compared to the width, where the ratios are the same? Turns out, okay, this is the big hint, so you don't have to do any work on this one, really. Well, especially because I chose a specific number. But it turns out that as you go along the Fibonacci sequence, you'll notice that like 5 divided by 3 is 1.6 repeating. 8 divided by 5 is 1.625. 13 divided by 8 is like 1.62. The further along the Fibonacci sequence I go, the closer and closer the ratio of one Fibonacci number to the previous Fibonacci number approximates phi, which is the special golden ratio, which is approximately 1.618. So since I gave you the shorter side, all you really needed to do, and this happened to be one of the Fibonacci numbers, all you really needed to do was pick the next Fibonacci number, 21. 21 divided by 13 is right around 1.618. Remember, we were going for the closest integer. We're not going to get it exactly. Okay? So that was that one. So that one was 21. Okay? If this weren't a Fibonacci number, like if the shorter side was, I don't know, 10 or something like that, how would we find this one to be in the golden ratio? Well, we could just say x over 10 equals approximately 1.618, and then we multiply by 10, and we get x is approximately 16, okay? That'd be the closest integer. Okay, number 6, it says you took a rectangle, you increased the length or width, whichever one it was, you increased one by 30 and you decreased the other by 30%, you decrease the other by 20%. So, look, I made it easy. I pretended that I knew the width and the length, and I pretended they were both the same, and I pretended they were both 10 because then my area would be exactly 100. Okay, now if I increase the length by 30%, what's 30% of 10? 3. So I increased it to 13. I decreased the width by 20%. What's 20% of 10? 2. So I decrease it down to 8. Okay, now I have an 8 by 13 rectangle, sorry. And then I multiply them, and 8 times 13 is 104. Since I made it 100 to begin with, how does 104 compare to 100? It's 4% bigger. It's a 4% increase. So by choosing the right square to start the problem, it made it a lot easier for me. Okay, this is problem 13, I think. It said Shohei had a batting average of 300. We say in baseball, we say 300, but basically that's 0.3 or 30%. Okay, if you're not a baseball person, that's how they write it in baseball. They call it 300. Okay, and it's the ratio of hits to at-bats. Okay, so if you are successful 3 out of 10 times, then you have a batting average of 300. Now, one of the things that you could have done, if you're not really well schooled in algebra yet, because I know some of you guys are like 6th graders, one of the things that you could have done is you could have said, look, for his batting average currently to be a perfect 3/10, we could have chosen, like, he either had to be 3 out of 10, or 6 out of 20, or 9 out of 30, or one of those, right? Because if it has to be tenths, it has to be perfect tenths, okay? And then he went 4 out of his next 5. So his hits increased by 4, his at-bats increased by 5, and when he did so, okay, he was 4/10. So his next thing has to be a perfect tenths, or maybe not quite, because, all right, this is an even number. So for example, 4/10 could also be 2/5. So his overall, like his final average could be something out of something, but the denominator would have to be a multiple of 5, because it would have to be either a 10th or a 5th, okay? So you could say he could have been like 4 out of 10, or 9 out of, did I say that right? 4 out of 10 is 2 out of 5, and then out of 15 be 6 out of 15, right? That's 2/5. Or 2/5 would be 8 out of 20. Or 2/5 would be 10 out of 25. Okay, so it has to be one of those. Or, let's see, 12 out of 30, and so on and so on and so on. Okay? And then we could just take one of these and add 4 and add 5 and see if it's one of these. 7 out of 15, not one of our choices. Add 4 here. Add 5 here. 10 out of 25. There it is. This was our original. There's the trick. We could have grinded it out. Okay? So the original amount of hits was 6. Algebraically, we could set it up as an equation. X over y equals 0.3. X plus 4 over y plus 5 equals 0.4. We could say, I don't know how good you are at algebra, but if I isolate the x, I can multiply both sides by y, and x is equal to 0.3y. I could substitute 0.3y in for x, and then rewrite this formula. 0.3y plus 4 over y plus 5 equals 0.4, and I just put it over 1 to make it in a ratio where I can cross multiply. I don't know if you guys have learned how to cross multiply. That times that is equal to that times that. So 1 times 0.3y plus 4 is 0.3y plus 4. 0.4 times y plus 5, it's like a distributed property. 0.4 times y is 0.4y. 0.4 times 5 is 2. Now I have an equation. 0.3y plus 4 equals 0.4y plus 2. I subtract 0.3y from both sides, I get 0.1y. I subtract 2 from both sides, I get 2. I divide both sides by 0.1, and I get y equals 20. So then we say, oh, the original y, the original number of at-bats was 20. So something over 20 equals 0.3, because it asks for the original amount of at-bats. And then I could say x divided by 20 is 0.3, so I multiply both sides by 20, and x equals 6. So the original amount of at-bats was 6, okay? I forgot the joke. I had the joke set up at the beginning. All right, I don't know if it's more of a joke or just a little story or whatever. You guys know pi. A lot of you guys know a lot about pi. It's called irrational. You can't write it as a ratio because it keeps going and never repeats. 3.141592655, 897, so on, right? And it goes and it doesn't repeat, so you can't make a ratio out of it because you don't know what to put it over. So it's called irrational. There's another kind of famous number in math called I. It's called imaginary. It's the square root of -1. What times itself is -1? Well, you can't do that because a negative times a negative is a positive, or a positive times a positive is a positive. So there is no number times itself that's -1. But when you get into high school and you start doing some calculus, you'll actually work with the square root of a negative. And it's called imaginary. I for imaginary. So here's it's a lot of setup for the joke, but here we go. So pi got into an argument with the square root of -1. And they're arguing back and forth. And finally the square root of -1 says, come on, pi, be rational. And pi comes right back and says, dude, get real. Because it's not real, it's imaginary. All right, have a great week. You guys are the best.